So we're reducing radicals. The only thing that's different is it has variables, x's and y's and z's or whatever letters under it, okay? So if you think about it, this really isn't any different than a number, okay? So x to the fourth, you might think of as, here, if I did a factor tree, it would be x squared times x squared, right? Or you could do x cubed times x, okay? What does x squared break down to? X times x, and what does x squared break down to? X times x. So how many pairs of x do I have? 2. Oh, that didn't work very well. 2 pairs of 2, right? So this is actually a perfect square, because see how there's nobody left over? There's no leftovers. So what's x times x? X squared. Okay, we're going to do that today, huh? So it's x squared is our answer there. It's a perfect square. In other words, what's x squared times x squared? X to the fourth. It's a perfect square. Something times itself. So it makes sense that there's no square root in our answer because it's a perfect square. Now we're going to kind of break it down like this a couple more times, but you're going to start to see a pattern here. It makes it really easy. So square root of 25x to the 6th. Remember, if a square root is over multiple things, you have to take the square root of both of them. So this is basically kind of like that. It's basically like the square root of 25 times the square root of x6. So what is the square root of 25? 5. It's a perfect square. And now, some of you might be able to think of it, but what times what? The same thing twice is x to the 6th. X to the 3rd, right? So that's our answer, is 5x to the 3rd. But the reason that is because x to the 6th is x to the 3rd times x to the 3rd. And each of these is x times x times x, right? So how many pairs of x's do we have?
3.
Yeah, x to the 3rd. So that's why, just like we do with our dates to prom on our warm-up spiral today, it's the same thing. There's just letters instead of numbers. So what am I doing to the exponent? Do you see a pattern yet? So there was x to the 4th underneath, and my answer was x squared. This was x to the 6th underneath, and my answer was x to the 3rd. Yeah, you're just dividing it by 2. That's all it is. So take the exponent, which is 6, and divide it by the index. And remember, the index is the number of the root. So like a square root's a 2, a cube root's a 3, a 7th root's a 7. Okay. So now that we kind of know that pattern, 3 should be easy. What's the 5th root of 32? It's a perfect fifth. It's 2. If you didn't remember that, how do I put 5th root in my calculator?
Math. 5.
I would do 5 first, so if you want a 5th root, type of 5. And then do math. And then the 5th one down says x root. That's how you type in a root other than 2 or 3. So the 5th root of 32, we can see is 2. Okay, now x to the 15th, I'll do this one last time. X to the 15th is x times x, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! Hand workout. It's an x. So how many pairs of x do I have?
Here.
Wait a second. Oh, it's a 5th root. Sorry, I'm going crazy. How many groups of 5 do I have?
3.
Yeah, so it's x to the 3rd. In other words, you're just taking the exponent and dividing it by the index. So the exponent 15 divided by 5 is x to the 3rd power. So what is y going to be? Y to the 4th. 20 divided by 5. The 5th root of 32 is 2. Okay, try and finish this out. 4, 5, 6. So what is the cube root of negative 64?
-4.
It's negative 4. In other words, -4 times -4 times -4 is -64. Okay. How many groups of 3 are made in r to the 6th? 2, and 3 goes into 15 how many times?
5.
So there's your answer. The cube root of -64 is -4. Okay, number 5, there's a negative in front. So there's this negative in front. And then what's the 5th root of -243? It's -243. So it's -3. So obviously there's a negative in front, and the radical simplifies to be -3. So what's that going to be? Yeah, so all that is it's just going to turn it positive because there was already a negative in front. And then a to the 2nd. That's it. And then the last one, the whole thing is to the 8th power. So what is 8 divided by 2? It would be 2x to the 4th. It's in parentheses to the 8th power, right? So does everyone see how I just got to where I'm at?
Yeah,
Yes.
you just square root it.
All you do is divide the 8 by 2, basically, right? But now, we can simplify that.
You get the square-
Time to wake up. So that's how this is how the square root simplifies. Okay, but what is 2x to the 4th?
16.
Yeah, and 2x to the 4th is 2x times 2x times 2x times 2x, which is 16x to the 4th.
Wait, you don't reduce the.
You get the same answer if you
What do you do?
calculate it. It's 30 square root.
Yeah. You can't plug x's into the calculator. But you should remember from first semester that 2x to the 4th is 16x to the 4th. And the whole thing is in parentheses, so the whole thing is multiplied out 4 times. So 2 times 2 times 2 times 2 is 16. X times x times x times x is x to the 4th. Okay, now what we need to do, if we go down to the bottom, it says, what if it doesn't come out evenly? Okay, so what I mean by that, so what is the square root of 16? Okay, that's good, right? Square root of 16 is a 4. What's the p going to be?
P4.
P to the 4th, good. But 7 does not divide by 2 because this is a square root, right? A 2 root. So if you think of it, q to the 7th is q times stupid q times. Let me restart my computer. Really struggling. So 2 root means pairs of 2. So how many pairs of q come out?
3.
Q to the 3. But then
Square root of 1.
exactly. Well, it's not square root of q. Yeah. So you're just leaving the leftovers inside, exactly like we do with numbers when we do de Sopran. So see how many times the root goes into q, and then just leave all of the rest of them inside of the root.
Whoa.
So when we're doing ones like this, what I like to do is I like to put a blank in front and then a square root, or this one's a 4th root, and then a blank inside, because I know some stuff's going to come out front, I know some stuff's going to stay inside. So first of all, let's simplify the 4th root of 32. Just like our spiral warm-up today. So what times what is 32? 8 and 4. 8 is 4 and 2. 4 is 2 and 2. 4 is 2 and 2. So this is a 4th root. So how many 2's do I need to come out? 4 of them. So how many groups of 2? No. 1 group of 4. So that 1 2 comes outside to represent the group of 4. And then how many 2's did it get to come out? Just the 1 2. So that's just the number part. That's not new. Like I could have given you that on your warm-up today. You should have been able to figure out the 4th root of 32 is 2 4th root of 2. Okay? But now we just have to deal with the variables. So how many times does 4 go into 9 without going over?
2.
Twice. So does everyone see how that would be a squared out front? because 4 goes into 9 twice. And then how many of those A's didn't fit into one of those groups? 1A. So there's 1A left inside. So we're just kind of sorting stuff. Now, how many times does 4 go into 20? Exactly 5 times. Were there any leftovers? No, so there's no B's left inside. So that right there is actually your answer. So 2A squared B to the 5th. Fourth root, make sure you write a fourth root, not a square root, of 2AB. It looks hard, but it's really not that bad. Okay. Now, last one, number 9. Remember, the fourth root of a fraction is the same thing as the fourth root of the top over the fourth root of the bottom. We learned that first semester. So, what is the fourth root of 1? 1, good. And what is the fourth root of 81? If you're not sure, put it in your calculator. So 4 math 5 is how I would type that in. 4 math 5. 81. Let me type it in so the videos. So 4, if you want to do a fourth root, 4 math, and then option 5 is x root. The fourth root of 81 is a perfect fourth. It's 3. So really, that's just 1/3. That big ugly fourth root fraction is just 1/3. Okay. And now we just need to sort our variables. So how many times does 4 go into 5 without going over? 1x. Now, fourth root of some leftovers, right? So how many x's did not get to come out? 1x. So put 1x inside the fourth root.
But then I thought it was 1x.
Say it, what? 1x came out and 1x stayed inside. Right? So one group of 4 and then one left over. And then how many y's, how many times does 4 go into 4? Exactly once, so 1 y comes out. No y's left inside. So that would be your answer right there. 1/3 was a perfect fourth. Or I guess I should say 1/81st was a perfect fourth.
So say like there was
So let's say I had the third root of x. Well, let me do fifth root. The fifth root of x to the 14th. The fifth root of x to the 14th. How many times does 5 go into 14 without going over?
3.
Without going over twice. And then fifth root of how many x's did not fit into a group of 5? X to the 4th.
Okay, so you put the 4.
So however many didn't fit into a group of 5. So there could be up to 4, right? Because what if that was a 15? Then it's a perfect fifth, and your answer would be x to the 3rd.